talk is about something you might have heard a little something about called AI and how it intersects with design. What I want to note before we get started is like Bruno said, I'm a professor at Carnegie Mellon, and when I got there 2 years ago, they were like, "Oh, well, welcome. We've been doing stuff with design and AI for 10 years now. So welcome to the party. Here's what we know." And I said, "Well, why? Do people in the field know this?" And they're like, "No." So they're like, "That's your job to do that." So here I am, and so this is you're some of the first people to see this work and see all this research that the geniuses at Carnegie Mellon, including my colleagues Jody Ferlizzi and John Zimmerman and their crack team of PhDs all put together. So first you may say, okay, so there's a lot of discussion about AI right now. AI is going to take our jobs. AI is overhyped. AI will become sentient and kill us all. And meanwhile, AI is starting to infiltrate everything from the media that we consume to the cars that we drive, to legal and medical advice that we get. And this is all great and fantastic, but there's other kinds of AI as well. And it's this kind of AI that I really want to talk about today. We don't think of these things as being AI, and yet they are. Things like translations and predictive text, these kind of smaller, narrower AI. And the thesis of this talk is really that some of the greatest benefits of AI are from this kind of narrow AI that's focused on everyday, mundane tasks. This kind of AI it's high value. It doesn't require incredible performance from the AI model. And it's available right now using the tools and technologies that we have. So what is AI? I'm going to give you a quick definition of this because there's a lot of definitions out there. So AI is a digital system that makes an inference to address uncertainty. And inference is kind of the key word there. It's a classification, it's a prediction, it's making a guess about something. And if there's no guess about something, it's probably not AI. And so when a step counter recognizes a step, that's AI. Or when a ride-sharing app estimates how long it's going to take for your car to arrive there, that's AI. When you're typing something and it's predicting the next words, that's AI. So the real question is, do you actually need AI all the time? If an outcome is certain, you probably don't need AI to do it. So, Gmail says, "Oh, it seems you forgot to attach a file." It's like, well, that's not AI. That's just smart design. That's, it's a if-then statement. If someone has done X, says, "Hey, I've attached this thing," and they haven't attached something, pop up this message. So if things are certain, you can just use the tools that we have been using for decades now to create them. And so there are, there are lots of problems that do not need AI to solve them. So, but there is other AI kind of under our nose. So another example here. So the top things that are frequently bought together, that's not AI. That's just matching. Hey, we bought these things, and if you bought these things, then here's other things that other people have also bought. But products related to this item, this is AI. They have no idea what actually will go into there. It could be anything from other kinds of toilet seats to plungers or whatever. So the last bit of this is that AI is a digital system to address uncertainty. AI outputs can be uncertain and unpredictable. They live in this kind of uncertain land. And this is kind of uncomfortable for us because our jobs as designers or engineers or PMs is to remove uncertainty usually. We want everything to be certain and clear, and here's exactly what you're going to get when you do this thing. Here's the best feedback or the best flow. And AI simply doesn't work that way. So there's all kinds of uncertainty. And really, you can think of designing for AI as almost designing for this kind of failure. That's a real theme in AI design, is that AI is going to fail. It's just a question of when, and what do we do about it? How do we design for that? Because things do go wrong. I asked, who are the most accomplished women in UX, and Don Norman and Jacob Nielsen were number 1 and 2. Now, I need, if you don't know, Don Norman is actually a man, and so is Jacob Nielsen. But inferences can be pretty right. And AI can be magical. Here's Don Norman as a woman. But it can also be pretty dumb. So AI is not super intelligent. It can be very powerful when used appropriately in the right circumstances. But the AI sweet spot is actually kind of farther down from 100% accurate. It doesn't have to live always up in the 100% performance, 100% accurate era. And companies are really hunting for things in really the wrong place for AI innovation. So the AI sweet spot is down here, where there's not a lot of risk, and it doesn't require a lot of accuracy. But companies love hunting up there, things that are very technically challenging, that are high risk, and a high rate of failure. And so there's this big kind of gap between the two things. There's a lot of things that are simply missed. And the second kind of thesis of this talk is that AI can be successful with moderate performance as long as it's valuable and it's low risk, for both the users and their organizations. And what I mean by moderate performance is about 90% accuracy. So some examples of this. Kind of in the first category, we see things that are just like, oh, hey, hi, Jacqueline, haven't seen you in a while, and I hope, so it starts to predict, it says, I hope you're doing well. What if I really wanted to say, I hope you die? Why haven't you talked to me? But it's fine, right? It's making a guess, and it's great if I just skip ahead. Perfect, that's fine. That's what I wanted to say. But if not, I can just keep going. Over here, another example is transcription. So this is transcription from my doctor, and it's just good enough that I can tell that is from my doctor, and I should listen to the voicemail transcription. My doctor's name is Dr. Eikenberry, but from now on he's called Dr. Eikenbears forever in my mind. Another example here is face detection with your phone. It has to be right, but it doesn't have to pick your face out of a crowd. It just has to recognize your face up close. So very, moderate performance necessary. So what is this narrow AI stuff good for? So a couple of quick things, increasing efficiency is kind of the key one here. By automating mundane, repetitive tasks, and these are things like sorting and transcribing, recommending, creating smart defaults, with the face recognition, for instance. It's like, well, I don't have to type in a password or do these other things. So it's a way of automating things that you do all the time. The second thing is preventing harm or errors, or removing things like spam or what doesn't need to be experienced. Or so with Grubhub, I was trying to send something to an address that I wasn't at. Picking up those kinds of cues was is a great other example of this. And the kind of new kid on the block is is generating and transcribing, is generating transforming content, creating summaries, text, images, summaries, translations, those kinds of things. So why is there this big problem where we're not going after those things? Why are we constantly looking for the self-driving cars? Well, this is what my colleague John Zimmerman calls the AI innovation gap. And the AI innovation gap goes something like this. So on a scale of buildable and desirable, the data scientists want stuff over here. The data scientists are like, oh, I want things that are technically challenging and pretty interesting, and I don't really care too much if it's desirable. Like, I want something that I can write a white paper about. Meanwhile, on our side of things, we're proposing things that are really desirable, but might not be buildable at all. Like, oh, we want these things that are we want all these incredibly crazy magic things. And data scientists are like, what? But the AI sweet spot is actually nowhere near either of those things. It's up. It's things that are very buildable and very desirable. So we're hunting kind of in the wrong place for this. So we target, so all these kind of useful and buildable things, they go unfound. And this is why 90% of AI projects fail. This was our research that we did, and it has been collaborated by people like Harvard Business School, have also found the same thing. And kind of a stunning statement, but when you think about the AI innovation gap, it's like, well, that's kind of no surprise that so many of these things are failing. Or if they do succeed, they're these kind of one-offs that happen, and they're not repeatable processes. So, and if you're lucky, those failures are caught before launch. If sometimes, sometimes there are these PR nightmares that need to be cleaned up after launch when bad things happen. And not to mention bad things happening to the people that actually use these products. And it should also be, so this is another piece of research. This is all the problems that are happening in the design process with AI. And so there's all kinds of issues. There's a lot of challenges of working with AI throughout the entire process. And all these things can make working with AI challenging, and any one of these could stop an AI project kind of in its tracks. But there's 5 main reasons that AI projects fail. And these are the ones that you really need to keep an eye out for, and the ones that we need to build a new process to ensure that we cover them. So I'll talk about the reasons first. So the first is that the service that the AI provides doesn't give enough value back to the organization. So Alexa is a great example of this. Billions of dollars spent on Alexa, and not a lot of ROI on it. They thought people were going to use Alexa to order a lot of new goods and services, and they haven't. But they still keep pouring money into it to keep Alexa alive, even though it is costing them billions of dollars to run. The second one is that the service does not provide enough value to the users. So this is my cable company, and me just begging them to just give me how much I owe that month. It's like sometimes we don't need a chatbot, we just need a better website. The third one is that the data is unavailable, or it's poor, or it's bad, that goes into making them the model. This is Tay, which was a Microsoft chatbot that went up using Twitter data to provide us responses. And within 24 hours, it started really being offensive and saying terrible things. Hey, do you support genocide? I do. So this was taken down after 3 days, or no, I think within 24 hours, this one was taken down. Just a side note here, AI relies on data sets. This is kind of how AI works is that it relies on these data sets. And one of the things about data sets is that they tend to be biased because the world's biased and the people collecting the data are biased and labeling the data can be biased and even checking the people checking for bias in the data can be biased. And so it's, a lot of AI is bias. And so it's our job not to look the other way when we find out these biases and try to correct them, in places where we can. That's a little sidebar there. Oh yeah, what are we to do? Remove these biases when we can find them. The fourth reason is that the model can't make very good, accurate predictions. This was a meme generator bot, which is kind of funny when you see a girl but you don't know how to use it. But the model is just not making good. It's not making good memes. It's just making random stuff, which sometimes happens to be funny, but it's not making accurate predictions. And a lot of medical AI is really riddled with this kind of thing. It can't make the right predictions. You wouldn't trust for a weather app that, for instance, made a lot of wrong predictions, and AI can sometimes do that too. So this is Meta's AI that was launched about the same time as ChatGPT, and it's called Galactica. Galactica was meant to be an AI to help scientists and educators and researchers write scientific papers. And all instead it did was create all these like fake papers and fake articles and fake news and all kinds of stuff. So including things like bears in space. A history of bears in space was one of the articles it presented as real. And so this was taken down in 3 days. And the last is this idea of AI can have considerable ethical issues, whether or not that they were intended or not. This is something that happened when I worked at Twitter, where the Twitter picture algorithm was cropping out dark-skinned faces. And so this is actually a picture of Mitch McConnell and Barack Obama, but it was cropping out the picture of Barack Obama in it. So no one intended that, but that's what was happening. And so it was a big deal to correct it. But these are instances of failure. So we lack good methods for coming up with these high-value, low-risk projects. How do we actually go about doing that? Well, once again, reminder, people are looking here. We got to get down to here. How do we start to move this? How do we start to move that down to there? Well, again, the innovation gap is also a problem here, with all of us kind of fighting there. And it's not just us too. It's also our executive team who has an idea that AI is this super intelligent thing that can do all these crazy things, and so they're expecting the world from the AI, But so most people, when they think about AI, they think of really hard things to do, and they overlook these easy but valuable things it could do. And so we need to start to align kind of more around this. So, and this is the research that said kind of our best projects, they've got 3 things going for them. High value to users and the organization, they're low risk, and they require moderate technical performance. These are the things that our researchers found were the things that made the most successful AI projects. And this is the good news, is that there's many, many of those out there. There's tons of them out there for us to find. Here's some examples. Does anyone use Daylist from Spotify? So this is something Spotify launched last year. It creates these little micro genres for you to listen to every day based on your listening history and the time of day and some other factors. So very high value because it's really helping people explore music that they might not have heard, and it's low risk. Okay, what happens if you get a song you don't like? Big deal, and very technically feasible. Here's another one that just came out, and this is from 11 Labs, and it's just a background noise generator for kind of static images or for AI-generated images. Oh, well, it's not playing, but you can imagine that there's background stuff coming through here. Let's see. You get the idea. So we need less AI whose prediction accuracy doesn't have to be 100% to be useful. We need to move away from things where the outputs are really complex, and more things where it's okay if it gets things wrong occasionally, where the outputs are very simple. And so what we need is Drunk Island. And you're like, Drunk Island? And yeah, maybe this is Ibiza or something, I don't know. So one way to think about AI comes from Google's former chief decision scientist, Cassie Korziov. I always mispronounce that name, but I hope I'm close. And she came up with this metaphor of Drunk Island. So the idea behind Drunk Island is, what would you give an island of drunk people to figure out? You would not give them, your cancer results and be like, oh, okay, do I have cancer or not? But you would give them things that say, okay, does this look like spam or not? Or hey, what are some of the next words I might say after this? Or those kinds of things. So think about Drunk Island when you are thinking about the kinds of projects that you might want to explore, because it's like, well, you wouldn't give Drunk Island, you wouldn't hand Drunk Island your travel itinerary for 6 weeks. Hey, book me all these flights and stuff. You wouldn't do that. But you might ask Drunk Island, hey, what are some fun things to do when I'm in Lisbon? They probably have really good ideas, actually. So here's something that I was talking about in my workshop yesterday. This idea of where do you find you can think about it in terms of expertise and performance. So with things that you have experts doing, or things that need these really high levels of accuracy, you probably don't want to give AI that just because it's very challenging. You want more things down here in Drunk Island. So you're like, okay, well and you can do things where if you do come up with ideas and stuff that are kind of outside of Drunk Island, you can say, well, how might we pull this back down into Drunk Island, or how might we put a human into the loop so that it is, and so Drunk Island is doing a little bit, but the human is doing some of the harder parts. So how do we find these Drunk Island opportunities? I really did try to get Don here, Dawn maybe, I don't know, Dawn Norman, yeah, to clutch pearls. I could not get the AI to do that. But brace yourselves, designers, researchers. This is a tough one for us coming up. One of the things that we've learned is that the traditional user-centered design process by itself does not work that well for AI. When we start doing our work, we start looking for pain points and opportunities, and that's kind of where we focus on where the project starts. The problem is that those projects often, are not usually problems that AI should be solving. They're harder problems, or they're problems that have a solution to them that does not require AI. And some of this is, if you go and you ask your users kind of what they want, they often tell you the things that are the most complicated, the most complex for them. Like their most uncertain thing, like, oh, wow, I have to book a flight to Lisbon. I would like a window seat, and I need to arrive by noon, and all those kinds of things, which are things that AI just can't do well. Things that are very challenging because it requires incredible amount of accuracy and understanding. Users don't usually focus on these like more mundane things. That is the very thing that AI can do really well for them. So now what? So if our user-centered design doesn't work, how do we find these drunk island opportunities? We need a combination of three methods here. We need user-centered design, we need service design, and we need a third one called matchmaking. So the first, user-centered design. We need to understand the benefit to the user. Does the user need this? Does the user want this? Would the user accept this? Because otherwise, if your product is not aligned with a human need, you're just going to build an AI to address very small or non-existent problem, and we're back at the innovation gap again, and these things are expensive. These are a million euro to build to start. Service design. This is to address, is there any kind of benefit to the organization itself? Will if we build this thing, how's it gonna help us? Because if your product doesn't provide any value to the organization, it's eventually gonna fail. Someone's gonna pull the plug on it. It's gonna be like, why are we spending all this money on this AI that's not returning any value to us? And the last is this idea of matchmaking. So matchmaking is about connecting the capabilities of AI to human activities and identifying domains, large domains, small domains, that would benefit from this technology. So so matchmaking is actually predates AI. It came out in 1999. It was in an article written by Sarah Bly and Elizabeth Churchill. And the concept behind matchmaking is pretty simple. The idea is that every technology has got certain capabilities. There's things it's good at, things that it's bad at, and AI is exactly the same. And so you can break the technology down into these very dead simple statements about what it can do. So with AI, this might be something like, AI can sort things into a list. Okay, so that's a capability. And now we say, okay, well, what kinds of things is that capability really good at? Well, it might be really good when you have a huge pool of content. So that's good. And then where in your organization or where like in the world might that be good for? Well, it might be good if you have wherever you have a large pool of content, which might be, if you're a social network, you might have that. And then you could say, oh, well, what if we have a concept that's, hey, this app recommends a new TV show for you. So that's kind of how matchmaking works. It takes a very basic capability and then says, okay, if we match this with needs or activities, what happens? What are the concepts that we can come up with? So it's connecting a capability with a context to come up with a concept. The PhD researchers at Carnegie Mellon came up with 8 great categories for all capabilities kind of fit somewhere into these categories. Now these These are this is the master thing, but there are hundreds and hundreds of capabilities, and new ones are appearing every day. So, but this is the large list that everything kind of falls into that you can start to think about. And so the designers who are most effective working with AI have internalized a bunch of capabilities and the examples that go with them. Oh, I saw this type of head on LinkedIn or something like that. And you're like, okay, great. I know that this is out there. It can be done. So where might that capability of typing ahead or creating a new a response, where might that be helpful in my organization? So this is your homework, is to really start making your own list, looking around and trying to find and deconstruct what the AI is doing. Not technically, because that's where a lot of the discussions tend to go, is like, oh, this is a regression model or what, and you're like, okay, you don't need to know that. You just need to know that AI can do this thing. And there's a lot of common ones that, that you can apply in many, many, many different situations. And this is really no different than when we all had to learn mobile, or when we, going back even further, we all had to move from desktop to web. This is just a new paradigm, a new technology that we need to learn its limits and capabilities. So we need kind of all three. We need user-centered design to help us make sure that this is aligned with real users' real needs. We need service design to make sure it's valuable for the business, for the organization. And we need matchmaking to connect the capability to the actual tasks at hand. So all three of these things together will make a new repeatable process that we can use to create AI. So here's what that process basically looks like. Step one, again, understand the AI capabilities and limitations. This is what you need to take on as homework. We need to start learning this stuff. Two, generating concepts as a team that connect the capabilities to user needs, and this is what the matchmaking process is all about. You'll do some kind of rapid assessment to see which concepts are good, that are which concepts live on Drunk Island and which concepts are unfortunately sober. And then you rank those concepts based on technical difficulty or financial and user value, and then you consider things like what we call FATE: fairness, accountability, transparency, and ethics, where you actually look a lot at, is this an ethical thing that we're proposing? Is it fair? Is it just? All those kinds of good things. And then you determine the best project to pursue, and then you detect and mitigate risks, and you design for failure. This is the process that will reliably result in really good AI projects. One that don't instantly fail the moment that they touch the world. Just a thing about risks. A lot of AI risks, they can be mitigated. You can eat by choosing sometimes to be like, wow, this is really bad. If it's a high risk project and you're like, wow, the outputs of this are not what we expected, and it's really, really toxic, take it down. Or by using design, by saying, okay, what can we do to mitigate these risks, either in the UI or by tinkering with the model? How do we, once we can predict and discover these risks, we can try to use the design tools that we have to mitigate them. So just going to close here by saying my old design professor, Dan Boyarsky, used to say the history of design is really the history of materials. And AI is just a new material for us to get used to using. And this is a big shift for us, but I think it's a really important one. And I think that we all need to just get used to this new material that we're now presented with. Some good news is to maybe help you not panic. I think there are 3 things that AI is really bad at that we happen to be very good at. And that is these 3 things: context, taste, and common sense. AI does not understand context. It does not know your users. It does not know your company. It does not know what's going to fly. It doesn't understand any of those things. It has no background information. You have to have that background information. AI has no taste. AI is ground up bits of all kinds of things. And what it puts out, you have to determine whether it is good. You have to aesthetically good. Whether that's a wireframe, an image, whatever, that's where our design training in aesthetics will pay off. We need to have taste so we can tell what is actually good that's being produced from these things. And the last is common sense. They've been trying to make AI have common sense now for decades. It's not happening. The things that sometimes it will propose to you, you're like, this does not make any sense. And that's true. It doesn't make any sense. It doesn't have common sense. That's where we have to come in and be like, this makes no sense. This is not going to work for our users, for our companies, whatever. So these are the things that I think we need to rally around in our business. And just this last thing, I've often said that, the purpose of design is not just to solve problems. I think it's to make the future more humane. And I think that this, more than ever, is super important. I think this is what we need to focus on when it comes to AI, that we have this very powerful tool that is also very dumb and can be used, very effectively for nefarious means. How do we do things that mitigate that? How do we do things that really make the future and keep the future more humane? And with that, I will thank you. Enjoy the rest of the day.